Artificial intelligence became an internet sensation overnight when OpenAI released an early demo of ChatGPT on November 30th, 2022. The chatbot instantly went viral on social media, and within just 5 days, ChatGPT was able to attract over 1 million users. However, despite its popularity, the majority of people don't know the basic ideas and principles behind this type of technology. In this video, we'll talk about artificial intelligence, types of artificial intelligence, how does AI learn, and we'll also explore the difference between popular terms like machine learning, generative AI, and large language models with real-life examples and popular applications you can start to explore today. Hi, I hope you're doing well. If you're new here, my name is Sarah Kurdi and I talk about technology, startups, and internet media. I also discuss how new technologies impact our life and society in the context of the Middle East and North Africa region. So if that is of interest to you, then you might consider subscribing to the channel and turning on the notifications bell so that you get notified when new videos are uploaded. I'd also recommend you watch the channel promo to get to know what we're doing here and the type of content you expect to see on here. I'll leave the link to the video in the description box down below. In the previous video, we briefly discussed the basic idea behind artificial intelligence through the case of AlphaGo, Google's AI program. I'll leave the link to the video in the description box down below, and I definitely recommend you watch it. We said that artificial intelligence is a type of technology that tries to simulate human intelligence to perform tasks like problem solving, learning, or decision making. Look, I know artificial intelligence might seem complicated or nearly impossible to understand without a coding background, but I promise it's fairly simple, and this is why this channel exists, to help you understand all of these new technologies from a non-technical perspective and to understand how they will impact our life and society in the future. In a nutshell, AI is a term used to describe machines that act smart. And guess what? It's all around us and we interact with it every day. When we unlock our smartphones through facial recognition or use voice assistants like Siri or use the spam filters in our email. We also talked about machine learning, which is the learning part of AI. It is how the AI system is trained on data and gets better at a task over time, like recognizing faces and predicting stock prices. Machine learning is algorithms that improve with experience. And if this video is suggested to you on YouTube, then this is machine learning doing its magic through the YouTube video recommendation system. The simplest form of machine learning is called supervised learning. It involves using labeled data to train algorithms to classify things or predict outcomes accurately. In supervised learning, researchers pair each training example with an output label. The goal is for the model to learn the connection between the inputs and outputs in the training data so it can correctly predict the labels of new unseen data. My favorite example of supervised learning that shows how AI will change the world of medicine comes from Stanford University.
Researchers here have developed an artificial intelligence algorithm that can screen X-rays for certain diseases. Computer scientist Pranav Rajpurkar shows me how easy it is to use. Take a picture of an X-ray with your mobile phone, upload the image, and a few seconds later, you get the diagnosis.
It's a mass, and it's saying this thing over here is a possibly cancerous lesion. Ooh. And I can see that right over here.
Okay, so it gives you, if I may have a look at it, now probabilities for pneumonia, a nodule, edema, effusion, and that goes bang.
Yeah.
Now, how does this work? I mean, how did you get to the point?
We started with a large data set of chest x-rays, which were released by the NIH, and these contained x-rays and then also labels of different pathologies and whether they existed in those x-rays. So it might say, okay, here's an image, and on this image I have pathology 1, 2, and 3. And we had 100,000 of these images. So we trained a model that can take as an input an X-ray and then output the probability of several different pathologies on this X-ray.
Like our brains, the network can learn how to identify tuberculosis, for instance. First, the network needs to be trained or taught. X-rays of tuberculosis patients are fed to the system. Initially, it struggles to correctly identify the condition. But every time an X-ray is fed in, the network's structure is adapted and its diagnostic ability improves. It takes thousands and thousands of clinical data sets to train the machine. Only after the network is optimized in this way can it correctly identify an unknown X-ray.
If you remember, we also covered artificial neural networks that are designed to mimic the complex decision-making process of the human brain. Now, we're more interested in a specific type of artificial neural networks called deep neural networks because it enables a process called deep learning. Unlike neural networks used in classic machine learning models, which usually use one or two hidden layers, deep neural networks include an input layer, hundreds of hidden layers, and an output layer. These hidden layers enable deep or unsupervised learning. Unsupervised learning uses multiple layers of neural networks to automate the extraction of features from large, unlabeled, unstructured datasets and make their own prediction about what the data represents. This means it doesn't require any form of human intervention and therefore enables machine learning at a massive scale. Deep neural networks are usually at play when it comes to generative AI or Gen AI, which powers most of the artificial intelligence applications we use today. Generative AI refers to deep learning models that can produce new original content such as long-form text, images, audio, video, or code based on patterns learned from existing data. Generative AI is the creation part of AI. It is a subset of machine learning that doesn't just analyze data, it generates original content in response to a user's prompt or request. Some of the popular generative AI applications we use today include ChatGPT, which generates text, DALL-E, which generates images, and Sora, which generates videos. And to give you a taste of what generative AI can do, here's Marques Brownlee, one of the leading voices in tech, talking about DALL-E and how it generates images.
What if I told you there's a system right now that can take natural language input, so whatever description you want, just make something up, and it will take that text and turn it into a surprisingly realistic image of exactly what you described. So you type an astronaut riding a horse, and it spits out a brand new image of an astronaut riding a horse. You type teddy bears shopping for groceries, and boom, there's an image of teddy bears shopping for groceries. You type a bowl of soup that is a portal to another dimension, and boom, my God, it's a bowl of soup that's a portal to another dimension. And it's not just one, it actually spits out 10 different versions across a spectrum of variation in any art style you want. So when I asked it for an astronaut riding a horse, for example, it's not just making a mosaic of images it found online. It knows the idea of what an astronaut is. It knows what the concept of riding means. It knows what a horse is. And maybe most impressively, it knows what's an aesthetically pleasing image to humans. So then it can create a completely new visual version of this idea that hasn't existed before.
One of the most widely used types of generative AI today is called large language models, or LLMs. Large language models are trained on huge amounts of text, and they are designed to understand and generate human-like language. LLMs can answer questions, summarize text, translate to languages other than English, understand context, and generate coherent and contextually relevant responses. They can also assist in creative writing or code generation tasks. We can think of large language models as the text and language specialists within the world of generative AI. One of the most popular LLM apps we use today is ChatGPT, which is considered the fastest growing app in the history of web applications.
ChatGPT, a chatbot by OpenAI that uses online resources to teach itself to communicate like a human. It can instantly compose completely original poetry, draft college-level essays, and build complex code.
When you interact with an LLM like ChatGPT, it might feel like you're texting with a human. But the reality of how these models work behind the scene is an entirely different story. Large language models are trained on a massive amount of text in the billions of pages to learn to predict the next word in a sentence based on the context provided by the preceding words. If this sounds a bit abstract, here's a video that simplifies how LLMs work that I found on YouTube. The channel is called 3 Blue 1 Brown, and they have an entire playlist dedicated to neural networks that I recommend you check out.
A large language model is a sophisticated mathematical function that predicts what word comes next for any piece of text. Instead of predicting one word with certainty, though, what it does is assign a probability to all possible next words. To build a chatbot, what you do is lay out some text that describes an interaction between a user and a hypothetical AI assistant. You add on whatever the user types in as the first part of that interaction, and then you have the model repeatedly predict the next word that such a hypothetical AI assistant would say in response, and that's what's presented to the user. In doing this, the output tends to look a lot more natural if you allow it to select less likely words along the way at random. So what this means is, even though the model itself is deterministic, a given prompt typically gives a different answer each time it's run. Models learn how to make these predictions by processing an enormous amount of text, typically pulled from the internet. For a standard human to read the amount of text that was used to train GPT-3, for example, if they read nonstop 24/7, it would take over 2,600 years. Larger models since then train on much, much more.
I think it's safe to say that artificial intelligence is among the most world-changing technologies ever, already changing things more rapidly than almost any technology in history. AI is gradually becoming part of every industry, from marketing and media to healthcare and education. AI can help you save time, improve productivity, and spark creativity by being your brainstorming partner. Therefore, learning the basics today can give you a huge advantage as AI continues to grow. If you like this video, then you might also enjoy the video where we talked about how AI surpassed human intelligence through the case of AlphaGo, Google's AI program. I'll leave the link to the video in the description box down below, and I'll see you next video.